So these are the answers to the exercises. And yeah, so what we need to know in order to find angle D is the fact that angle A and angle B are congruent in a isosceles trapezoid. And then angle B and angle D are supplementary. And we know that because we have parallel lines cut by a transversal. And so those two angles are the consecutive interior angles, which are supplementary, right, equals to 180. So this angle here would be 180 minus 125. Okay. So this one here, we're trying to find angle L. Same idea, right? We have two parallel lines cut by a transversal. These are the consecutive interior angles, and they're supplementary. So we can find that angle. And down here, we're going to be using the fact that base 1 plus base 2 is equal to 1/2 times the mid-segment. And that's the formula that we're going to be using here. So this would be hj, or the length of hj, plus the length of lk divided by 2 is equal to the length of mn. Right. So that's going to help us solve all of these problems because we just plug it in. 32 here, 60 here. We add them together, divide by 2, and we get mn. But if they give us the mid-segment's length, like they do for number 4, then we just go and plug in, right? So we got 18 here, 28 here, and we're solving for lk. Right, so that's what we're doing for problems up to number 6. And then, up to number 5. And then number 6, they give us these top base angles. So this is 140 and this is 125. If this is 140, we know that the base is parallel to the other base. So we have a transversal cutting through the two parallel lines. And actually, this one is actually parallel as well, the mid-segment. So we have a transversal cutting the two parallel lines. So that means that these two angles are supplementary, right? Consecutive interior angles supplementary. And then angle FVY is congruent to angle FVC because this is corresponding angles, right? And so we're going to use that same idea on the right side as well because they give us angle E as 125, so we can get these two angles here. And so we're verifying if RST is a trapezoid. How do we do that? Well, the two bases need to be parallel, and then the sides would need to not be parallel. And so we're going to find the slope of all of these lines and compare them. Right? And then to determine whether it's isosceles, we need to get the distance of the legs, so the distance of RU, the distance of ST, and we can see that they are not equal. So it's not isosceles. All right, so let's come over here to kites, and a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. So here's our kite, and we have these two are consecutive sides, and they're congruent, and these two sides are consecutive, they're right next to each other, and they're congruent. And so this here's a kite. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. Right? So side MR is not parallel to NP, nor is it congruent. Right? If it was congruent, then that means that this would be a rhombus. Right? But they're not congruent, which is why we get this kite shape, and it doesn't look like a rhombus. So here, the diagonals of a kite are perpendicular. So for our kite here, our MP is perpendicular to RN, which means that this angle here is a 90-degree angle. This angle here, here, and here are all 90-degree angles. In a kite, exactly one pair of opposite angles is congruent. Okay, so what does that mean? That means that angle M, this big angle here, is congruent to angle P. Only one pair of opposite angles is congruent. Angle M is congruent to angle P. And angle N, this angle, is not congruent to angle R. Exactly one pair of opposite angles is congruent, right? The sides of the kite, we could say, are congruent. Okay, so these are the properties of kites, and now let's use them to solve some problems. Here we have this shape here is quadrilateral, is a kite. We need to find angle Z. And by finding angle Z, we find angle X, because they're the pair of congruent angles. So how do we do this? Well, we need to go back to the sum of the angles of a quadrilateral. Right? Remember that formula for the sum of the angles is equal to n minus 2 times 180. Right? So if we have the sum of the angles of this quadrilateral, we can use it to solve this problem. So n, remember, is the number of sides in the quadrilateral. So it's 1, 2, 3, 4 sides. So it's going to equal to 4 minus 2 times 180. So then that equals to 2 times 180. It's equal to 360 degrees. Okay, so we have the total sum of all the angles of the kite. And now we don't know what x or z are, but we do know that they are congruent. Because the kite has exactly one pair of opposite angles congruent. And these two opposite pairs are not congruent, which means that x and z must be congruent. So we could say that 360, the sum of all the angles, is equal to 80 plus the measure of angle z plus 60 plus, and here I'm just going to put here the measure of angle z again, okay, because these are both the same measures. So measure angle z again. Or we could use a variable, right, like x, but this angle's name is x, so it's kind of confusing. Anyways, I'm going to say measure angle z for this angle, measure angle z again for this angle. And that's what we're trying to solve for, measure angle z. So now we can solve for measure angle z. So combining like terms is equal to 140 plus 2 times the measure of angle z. We'll subtract, we get 220 is equal to 2 measure angle z. We divide both sides by 2, and we get 110 is equal to the measure of angle z, and that's our final answer. Right? So this angle here is 110, this angle here is 110, and that's our answer. All right. So let's look at the next problem. Is if a kite, so this here is a kite, our congruent angles would be B and D. Our diagonals are perpendicular, which means that this is a 90-degree angle, and all of those little angles there are a 90-degree angle. And what are we trying to find? Use the Pythag theorem to find the missing length. And so what is the missing length? I guess what we want to find is the length of AB, which is also the length of AD. And we also want to find the length of BC, which is also the length of DC, right? Because we know that consecutive sides of a kite are congruent. Right? So yeah, let's find AB. So measure of AB is going to be equal to, so we're going to use Pythagorean theorem, right? So Pythagorean theorem is leg 1 squared plus leg 2 squared is equal to the hypotenuse squared. So 5 squared plus 4 squared is equal to hypotenuse squared. So our hypotenuse is AB, so I'm going to say AB squared is equal to leg 1, which is 4 squared, plus 5 squared. Leg 1 and leg 2, right, is equal to the hypotenuse squared. So now we're going to say AB squared is equal to 16 plus 25. We're going to add those two up and get 31, 41. So then to solve for AB, we need to take the square root of both sides. So we're going to get AB is equal to the square root of 41. Okay, so that's an awkward number. Let's see if I did that correctly. 4 squared is 16, 5 squared is 25, 30, 41. Yep, that looks right. So that means that AB is 41, and also AD is 41. So I'm going to say AD is equal to square root of 41. Now we need to find the other sides, and we're going to do that the same way because we know that diagonals of a kite are perpendicular, which means that's a right angle, and that's a right angle. Right? So we can use the Pythagorean theorem again to find the length of BC. So let's go ahead and do that here. So we're going to say leg 1 squared is 5 squared plus 12 squared, which is the other leg, is equal to the hypotenuse squared, which is going to be BC squared. So we'll get 25 plus 144 is equal to BC squared. We'll add the 2, and we'll get 169 is equal to BC squared. This is a better number. We'll square root both sides, and I believe 169 is 13. So BC is equal to 13. Let me double check that. So do 13 times 13. Yeah, 169. So BC is equal to 13, and also DC is equal to 13. So I'm going to say 13 is equal to DC as well. Right? And so that's how we solve some of these problems using the properties of a kite. Again, the properties of a kite are consecutive sides congruent, one pair of opposite angles congruent, meaning the sides angles of the kite are congruent. The diagonals are perpendicular. And so that's how we're going to use those properties to solve problems involving kites.